GM Arbinauts, and welcome to the first virtual Arbitrum Day. We'll have a full day of virtual talks and we'll be getting insights from amazing people who are building the Arbitrum and Web3 ecosystem. The latest insights on scalability, account abstraction, interoperability, data availability, and gaming. And don't worry, these sessions will stay recorded for you to watch it over and over again. So yeah, you will be able to do that soon. And before we start, we want to highlight what is Arbitrum. And well, Arbitrum is a technology suite designed to help scale Ethereum. You can use Arbitrum chains to do all the things you do in Ethereum, like use Web3 apps, deploy smart contracts, etc. But your transactions will be cheaper and also faster. And at the end, it's more inclusive for everyone to use it. And yeah, Arbitrum is Arbitrum 1, Arbitrum Nova, Arbitrum Orbit, and as well, according to the organization that is called Layer 2B, is the most decentralized and advanced Layer 2 solution at the moment. But it's not only that. Arbitrum is so much more. Arbitrum is the Arbitrum DAO, the Arbitrum Foundation, and hundreds of projects that are working together with many talented people and enthusiasts that pave the way for a better present and as well a better future. And we are helping each other to achieve this. And yeah, this is Arbitrum and you are part of it. Thank you for joining us today and let's get started. I'm very honored to introduce our first speaker, and is Vitalik Buterin, the Ethereum's co-founder and one of the brightest minds in the ecosystem. And yeah, Vitalik will share a keynote about EVM improvements that Layer 2's could experiment with. Hey, thank you, Vitalik. How are
Yeah,
you? Are
thank you.
you
Thank you
attending?
so much for the kind introduction, Anna. I'm great. How are you?
I'm great too. Thank you. Here in Mexico, greens for Mexico. I saw you during the event as well there. So yeah, happy to have you here.
Yes. Yeah, it's
So
amazing. Okay, let me just select the PDF and I'm going to go and share it. It's processing media. Um, yeah, but I guess while it's doing that, so the thing that I wanted to present about today is basically just go through some improvements to the EVM that Arbitrum and potentially other layer 2s could experiment with. Right, so basically, yeah, looking through some different ideas for the EVM that have been tried in the Ethereum, or that have been thought about in the Ethereum ecosystem. In some cases that have been thought about in other ecosystems, but that have not been done on layer 1, and some opportunity for layer 2 to innovate, both to start kind of diverging from layer 1 and to try to really go forward on prioritizing of functionality in ways that layer 1 is just not going to do, and also to be as a test bed and try out some changes ahead of the layer 1 that might then be incorporated into the layer 1 over time. So lots of EIPs have been proposed for Ethereum, right? And lots of those EIPs do not survive. So if you go to eips.ethereum.org, you can see a big long list of EIPs. You can see a big long list of EIPs that made it. And you can also see a whole bunch of EIPs that have not made it, right? And a lot of the time, these EIPs get rejected for all kinds of reasons, right? Sometimes they get rejected because it's just like that whole category of thing that they're trying to do is just not worth the cost. Sometimes they get rejected because we discover a much better version to achieve the same objective. But sometimes they just get delayed just because there's no time and because the core development process for layer 1 is highly conservative. And so people are not only willing to like really put a limited number of things in layer 1, but just even if something gets rejected, it might still be a good thing, and it might still be something that's actually worth trying out in a lower risk context. So layer 1 in general highly values simplicity and stability, but layer 2 has a position where it can afford to be braver. And so the thing that I think we should be thinking about is what are some concrete ways in which layer 2 can be braver that layer 1 either does not have access to in general, or maybe that L1 does not have access to in the short term, but then once something has been tested at layer 2, it actually can be brought over into layer 1 at some point further in the future. So let's start with some basics, right? SecP 256 R1. This is probably like by far the simplest thing to try to do on a layer 2, and it's like, from a technical perspective, not very interesting, right? Because SecP 256 R1 is an elliptic curve. It's the exact same algorithm as SecP 256 K1 that EOAs and Ethereum use, that accounts in Bitcoin use, that all kinds of things use, except it has a couple of different constants, right? And so if you want to add SecP 256 R1 verification into an Ethereum client, you'll only need to add like maybe 10 lines of code. But the reason why it's valuable is because there has recently been a lot of interest in account abstraction, and there's recently been a lot of interest in making wallets that have better forms of security. And one of the directions here is using keys that are inside of trusted hardware modules, right? So users have keys, like basically if you have a phone today, right, your phone probably at this point has a TPM, and inside of the TPM there are keys. And your operating system has a way of accessing those keys where the amount of code that those keys are exposed to is much, much smaller than the entire operating system, right? And so even if the operating system as a whole has a bunch of big bugs in it, the trusted hardware module probably is still going to be secure. And so we have keys in these TPMs, but unfortunately the TPMs at present generally don't support SecP 256K1, but they do support SecP 256R1. And so if you have a wallet where the verification function of your account on chain uses SecP 256R1, then you can use these keys that are in your TPM inside of your phone to control your coins directly. And so even if your phone gets hacked, you would still have an extra layer of security. So in order to make this happen, basically we need to have SecP 256R1 verification on chain. Now you can implement it in EVM code directly, but this costs like apparently something like 200 to 300,000 gas. So it's a little bit expensive. And unfortunately, EVM Max, this is the modular arithmetic standard inside of EOF, even that does not really improve things by that much. But if you just have a precompile, then obviously you can push the gas cost all the way down to 3,000, because 3,000 is the gas cost for the precompile for SecP 256K1. Now, at L1, there's just a limited budget and a limited appetite for accepting precompiles, but L2 is one of those things where they just like can go ahead and accept this. There's an effort now called the Roll-Up Improvement Proposal effort, RIP. Unfortunately named, but still, great standard. And I hope that all the layer 2s can be part of it. Basically trying to get some EIPs accepted at the layer 2 level across many layer 2s, and then potentially get accepted at layer 1 later. And SecP 256R1 is one of the primary targets there. So that's the easiest one. Now let's move on to some of the more interesting ones that are a bit more challenging. BLS 12381, right? So the EVM already has opcodes for doing cryptographic pairings, right? So Tornado Cash used them, Privacy Pools used them, Aztec uses them, but these operations are all done over the BN128 curve. And the BN128 curve is slightly less secure than BLS 12381, like it has about 105 bits of security or something close to that instead of 128. And BLS 12381 is the one that's more widely standardized. It's also the one that Ethereum itself uses. And so if you want to make things that are compatible with Ethereum itself, then you're going to want to use the BLS 12381 curve. But this requires a precompile. There's an EIP that's like basically finished, but that has not been included into Ethereum itself, but that can be included into L2s. Bigger one, enshrined account abstraction. So ERC-4337 is a hot topic. It's powerful. It lets you really increase the number of possibilities for how you can secure your account. But it does have the weakness that it's a pretty complicated proposal that is going to take quite a bit of time before layer 1 is willing to accept it. And so in the meantime, it is purely an off-chain standard, and it is done that way with the help of like Flashbot's style, like second layer builder markets and a bit of other infrastructure, but it would really benefit from being enshrined. And experimenting with enshrining it at layer 2 before doing that at layer 1 is also something that can be done, and is also something that the roll-up approved proposal group is interested in doing. And so that's another example of something that layer 2s can go ahead and just do ahead of the layer 1 doing it. So those are some basics, but now that we've gone through the basics, I want to try to get into some deeper stuff. EVM parallelization. So the EVM is not a parallel system by default, right? Transactions get executed in series, and this puts a limit on our ability to scale it. If you want to process many more transactions per second, then you have to do something other than just have one EVM. Now, in principle, layers 2s solve it in some sense, but even within a layer 2, you have the exact same problem, right? Because within a layer 2, someone has to run a full node of the layer 2. And if someone runs a full node of the layer 2, then they themselves are also limited by the EVM's limitations. And so the numbers that we talk about, how EVM layer 2s can increase Ethereum scalability from like 20 TPS to like 6,000 TPS, those basically implicitly assume that you have a whole bunch of different rollups that are operating in parallel. The problem is if you do that, then you lose a lot of composability. You have a lot of extra costs moving between one rollup and another. You have to use cross-chain protocols a lot. But if instead you could make a smaller number of rollups where within one of those rollups you would parallelize the EVM, then you could really solve this problem, right? You could imagine like Arbitrum by itself individually doing 1,000 TPS within the context of something that from the user's perspective kind of looks just like an EVM, and they don't really notice many differences. EIP 648 is a proposal from many years ago for a concrete way in which the EVM could be modified without too much difficulty in order to actually do this. And EIP 648 basically says transactions specify the range of addresses that they can access. And they use a pretty simple language to try to do that specification. So basically just like a list of prefixes that a transaction is allowed to access. And then there are gas rules where essentially the gas limit only takes into account transactions that have intersecting gas access ranges, right? So if you have two transactions that are beside each other, or even 10 transactions that are beside each other in the transaction list, but that have disjoint access sets, then the gas cost of those 10 transactions only equals to the gas cost of the largest one of them, right? And so you could basically include a much larger amount of gas in a block only if those transactions actually are disjoint. If those transactions are not disjoint, then, well, guess what? You still have 30 million gas in a block, right? So basically trying to do parallelization as much as possible within the context of the EVM being roughly as is. This is something that unfortunately did not really ever get deeply implemented or thought about in a layer 1 context, but this is absolutely something that I think Arbitrum or any layer 2 could very easily go and experiment with. And if you do this and you do a good job of this, then like you could really make something great for your users. So that's parallelization. Adding alternate VMs. So this is something that I know Arbitrum Stylus is already interested in doing because the current Arbitrum Stylus approach lets you basically have EVM contracts and WASM contracts within the same system, which I think is absolutely great. There are other options for VMs, right? So WASM is obviously one. You could also do Cairo or other Snark or Stark-friendly VMs. And you could also do something new that compiles efficiently to both of these. One of my philosophies here is that the cost of adding a new VM is large. And the reason why the cost of adding a new VM is large is because the EVM is going to be very hard to get rid of. And so if you have a new VM, then like realistically, you're going to support the EVM and that VM. And like that adds a lot of code, that adds a lot of like software bug attack surface. It's not very nice, right? And so The absolute worst thing that we can do is add a second VM and then 3 years later regret it and realize we're going to add a third VM. And so I think if we're going to go into the alternate VM direction, one thing that I would love to see is basically just like do a really proper research and thinking effort and try to figure out like what is the VM that satisfies basically a grab bag of all of the goals of all of these different VM approaches, right? So the ideal VM to me would, one, efficiently compile to WASM, so you can just use existing WASM tooling to run it. Two, it would efficiently compile to some kind of Snark VM or Snark circuit language, so you could really efficiently use Snarks to access it. Then three, as formal verification friendly as possible, right? I know the Cairo language really values this, but there are other ways to formally verify things as well, and potentially other goals. And like you could try to make a new VM that just efficiently compiles to all of these and just tries to like really do a good job of satisfying all of people's goals as much as possible, right? And then if you support that and the EVM, you could do that. Or you could support that and just write the EVM in that VM, and then you would support one VM, which would be simpler, right? So you have a lot of different options. And you could even imagine the Ethereum L1 at some point in the future going in this direction. And like maybe that would be the way in which Ethereum sort of gets rid of the EVM at L1 in 10 or 20 years time, right? Make a new VM that's really amazing, that satisfies all these goals. And eventually we cut code size by just replacing the EVM with a contract written in the new VM language. So a lot of interesting things to explore in the alternate VM path as well. EOF. So EOF is the Ethereum object format, and this is basically an approach that is being strongly considered within Ethereum L1 core dev circles for how to extend and add features to the EVM, while at the same time trying to constrain it and make it more friendly to optimization strategies and compiling strategies that depend on the EVM having constraints. So this is ELF version 1, consisting of some basic EIPs, EIP 3540 and 3670, which is just like basic format stuff, and then adding functions and like really basic stuff like that the current EVM does not have. And then there are other EVM improvements proposals that are currently being built, that are being built within the context of EOF, and that take advantage of the more constrained nature of the EOF. So one of my favorites is EVM Max. This is the modular arithmetic extensions, which is a series of proposals that basically make it much easier to do large amounts of modular arithmetic, which could make it much easier to directly implement many kinds of cryptography in a way that is potentially within 2x of the efficiency of precompiles, according to some numbers, but without requiring precompiles. SIMD, single instruction, multiple data, so allowing large amounts of parallelism. Greg Colvin, brilliant researcher, wrote an EIP on that quite a long time ago. So there's a lot of different ideas that are being floated around that could be implemented within the context of EOF. And EOF is another example of this sort of thing that could easily be done across layer 2s before it's done on layer 1. Or you could even imagine specific changes that are being done within EOF, even being experimented on by individual layer 2s, right? I mean, you could even imagine like implementing WASM as an EOF feature. And if you do that, then like you've done it in a way that's sort of maximally compatible with all of the other stuff that other people are trying to do, right? So EOF is something that I think if L1 doesn't do it very soon, the roll-up improvement proposal group should absolutely do. And within EOF, that's a lot of room for open experimentation. So a lot of really interesting and fascinating things that can be done inside of that. State size control. People have probably heard of words like blockchain rent, state expiry. These are all strategies for limiting the state size, which is the size of the amount of data that a node that is processing and creating incoming blocks has to store in order to create those incoming blocks. There is an EIP that I created for a state expiry about 2 years ago that is basically just sitting there because we've decided that at layer one it's going to take too long until we actually get there. And once we have Merkle trees, once they have statelessness, then like the L1 can survive without it for quite a long time. But it's possible that layer twos could totally take advantage of it, right? Like it could be the case that when you do the math within your layer two, you realize that like actually what is the bottleneck is not even computation, it is state size. This is actually something that I think is true in a lot of cases, right? Like the last couple of times I remember poking into some of these alt L1s that promise like, oh, we can support 25,000 TPS because we have this like super amazing transaction consensus stuff. Like they can't. But the thing that breaks them first is not limitations that have to do with computation. It actually is state size, right? Because if you have 25,000 transactions per second, and then if even a fifth of them are creating new accounts, and let's say a new account is going to be like 200 bytes, 200 bytes multiplied by 5,000 transactions per second creating an account, that's a million bytes per second. And then a million seconds is about 11 and a half days. And so every 11 and a half days, you're adding a terabyte to the state. And then the state just keeps on growing and then your chain becomes horribly centralized, right? So experimenting with state size control is, I think, something really interesting that especially layer twos that are interested in going the kind of very high scale direction could try to do. And I think some of these state expiry EIP ideas that have been worked on within Ethereum research circles over the course of many years are actually a really interesting place to start. So within this, there's a lot of kind of sub ideas, right? There's the whole address space extension and address space contraction problem, which is another place where L2s could experiment. So you could even imagine just like making addresses be 32 bytes from the start or potentially doing something else. Then the Verkle trees, obviously, and trying to experiment with like programming languages that try to design around state expiry. There's a lot of interesting things that I think could be tried here. Next one is asynchronous communication, right? So if you care about parallelization, which is, I think, going to be necessary if you want to do the thing where you make an L2 that has really high scale, then you're probably going to want to use async communication because when you super scale to that extent, aside from state size, synchronous communication is generally the main bottleneck. There have been ideas for async communication that have been developed within Ethereum circles. So back in 2015, there were some interesting ideas. There was a post opcode, which is like a call, except the call would get executed after the rest of the transaction finishes. And then there's this alarm opcode, which would function like post, except it would execute the asynchronous call in some future block. It turns out that like the economics for alarm are just super complicated and hard because you have this problem of like, what if a million people over the course of a million blocks make alarms that all execute in block number 1 million, and then block number 1 million suddenly takes 5 hours to execute and no one can do it, right? So like that was the big problem that is really hard to deal with, and you just end up needing a lot of complexity to end up getting around that. But other forms of async communication, the post approach was one. Also, the whole history of Ethereum's 5 years of research in attempting to figure out how to do sharding. There's been a lot of stuff happening there. And the post-up ideas for how to pass messages from one shard to another shard, ideas for how to do gas costs for messages as they arrive into individual shards. Like if you just search Ethereum sharding proposal for, and especially go to ideas that are like between maybe 2017 and 2021 or so, you'll find that like at least a third of the discussion has to do with how to do async communication between shards well, right? And so if you, there's a lot of those ideas that I think are amazing, and Ethereum never ended up implementing them at layer one, but I think they are absolutely ripe for implementation at layer two. Finally, this is the last one, EVM simplification, right? There's a lot of EVM simplification ideas that I think are really valuable and that could get tried out. One is removing or simplifying logs. So the case for removing and simplifying logs is basically that the entire Ethereum logging mechanism basically evolved in a context where ZK snarks did not exist, fraud proofs did not exist, cryptographic accumulators did not exist, and also we thought that it would actually be viable to do the whole thing where you do a Bloom filter query across the entire chain. What we've discovered since then is that ZK snarks exist, complicated cryptographic data structures with powerful properties exist, and the whole thing of doing like Bloom filter queries across the entire chain as a client locally is just not efficient enough in practice. And so dApps that depended on it, lots of them basically just end up switching to the graph, right? And so the question is like, maybe we should get rid of logs, or maybe we should simplify logs so all they do is they just like make a hash record or something, and we don't bother making the hash record fancy, we don't bother with Bloom filtering, we don't bother with the concept of topics, and just make logs be a really simple thing. And once we do that, then you can just like we work as hard as we can at making things like the graph be as powerful and as decentralized and resilient as possible, and then encouraging dApps to rely on those. So this is a type of EVM simplification, and it's again something that layer 2s could possibly consider. Simplifying call and create types, right? So today we have call code, delegate call, create two. Realistically, like only 3 of those need to exist. Maybe you can come up with fancy ways where only 2 of them need to exist, right? Maybe we could get rid of delegate call and we could instead have an enshrined feature where every account just like has a code address that stores what is the address where its code is stored at. You can think of a bunch of different things and experiment with simplification there. Remove or simplify precompiles, right? There's a lot of precompiles that are being underused. You could imagine replacing the RIPE MD160 precompile with a piece of EVM code that does the same thing. My personal opinion is that L1 should do this eventually. Maybe L2 should start. Simplify gas mechanics. There's a whole bunch of VIPs around this. One is around making gas more opaque so that like you don't need to do gas tracking within each individual level of calling. Another one is change how the gas accounting of mload works, and basically have a more clear mathematically defined bound on what is the maximum number of bytes of memory that if the EVM can use. So there's a lot of really interesting things that I think could be done within the space of simplifying gas mechanics. So conclusion, right? There's lots of VM ideas that have not been tried, lots of VM ideas that have been discussed for a long time, and have been rejected for reasons that are not about the idea being low quality. They've been really delayed or rejected for the reason that has to do with the L1 being necessarily conservative. L1 is slow, but maybe L2 can be faster. And so maybe L2s should actually try a bunch of these VM ideas. And it would be, I think, amazing to see Arbitrum taking the lead and doing some of this stuff.
Great, fantastic. Thank you, Vitalik. This was amazing. Like, thank you for sharing your knowledge and also research. This has been incredible, and I think it's giving guidance and ideas to implement and strengthen the Ethereum and Layer 2 ecosystem for sure. And we have a question from Harry Kalodner. This was asked while you were sharing about Arbitrum Stylus, and the question is, how do you think about Ethereum compatibility in a world where layer 2s start deviating from the EVM more? Like, for example, what if Ethereum adds another address at an existing protocol address?
Yeah, I mean, I think one important thing is like I personally definitely do not think that like if you start deviating from the L1 EVM that this counts as like being disloyal or being Ethereum unaligned or any of those things. And to me, part of the goal of the layer 2 ecosystem is to open up space for experimentation. And so I think we need both layer 2s that stick strictly to the EVM and layer 2s that go in different directions, including expanding and also including contracting. So I think it's great to do that. experiment in that direction. I think the valuable thing is for us to really agree on like what are some common set of standards that we all want to stick to and that we all want to work together on as we start doing those things. With an eye to, for example, making sure that it continues to be possible to have account abstracted wallets, making sure that like cross-chain address standards work, making sure that things like light client protocols across layer 2s continue to be possible, making sure that just like wallets work in general. So if we can like agree on that core set of standards, something that is more restrictive than just saying you have to support a particular key elliptic curve, or more expansive in the sense of like more requirements than just saying you have to support a particular curve, but much less requirements than like supporting an entire EVM, then I think that would be like really amazing to see. And I hope that all of the L2 standardization work that we've been seeing can start going into covering that.
Great, thank you, Vitalik. Well, I think that's we have more questions, but we can ask you in another time. Thank you so much for today for
Thank
joining
you.
in the first Arbitrum Day virtual event today. So yeah, enjoy Istanbul and see you soon. Thank you for joining us.
Thank you. See you too. Okay.
Ciao.